Hello class. In this video, I will be discussing the answers to the example problem that I gave in the PowerPoint for kinematics in one dimension. So we start with the first question or requirement. So in the PowerPoint, the example problem, it says there that there is a particular particle whose position as a function of time is given by this. So you have t squared minus 4t plus 2, and then all of the units here will become meter. Requirement A, we have to illustrate or sketch or make an xt graph or a position versus time graph for the interval between 0 to 5 seconds. So how do we do this? First is we just put in different values of t from 0 to 5, and then we will also have a corresponding values for the x, meaning at any time that we put here, we substitute here, that will be the position of that particle. So let's do that. So, plugging in the different time values from the x as a function of time, we have here x when time is 0 is positive 2, x when time is 1 is negative 1, negative 2 meters, positive 2, 1 time is 3, and so on. So, these are now the values of our positions. These are all in meters. We can also present this in tabular form. So, in tabular form, that would be something like this. We have the time values and the x in meters. So these values are just orderly placed in a table. So these now are different points, okay, which we will plot in our x as a function of time. The time values are the x-coordinates or plotted along the x-axis, and the position values are plotted along the y-axis. Okay, so our position time graph, in choosing an interval, you look at your values. So in the time, since our interval here is just by 1, then we can have our time interval also as 1, 2, 3, 4, by 1 then. And if you check your position values, the biggest negative number is negative 2, and the largest positive number is 7. So to maximize the space in your graph, we can have the interval also by ones, but shorter dito, so that we'll be able to maximize the space. So by pair, we will plot them one at a time. So when time is 0, you have there positive 2 for your position. Time 0, positive 2. This point corresponds to this pair. And then you have 1, negative 1. So 1, negative 1 is somewhere here. Time value 2 seconds, negative 2. Time is 2 and then negative 2 somewhere here, more or less. When time is 3, you go negative 1 again, going near the 0x. So negative 1 when time is 3, somewhere here. When time is 4 seconds, the particle is at 2 meters to the right again of the origin, somewhere here. And then when time is 5, it's positive 7. Somewhere here and here. So more or less somewhere here. Okay? So since your position as a function of time is a quadratic equation, then your best fit line will be parabolic, not linear. So our best fit line, we'll just connect we will estimate the curve where it touches almost all of the points. So more or less, the curve would be somewhat here. Oops. There you go. So you have two kinds of curve lines here. Okay? You have this and this one. But, I'm sorry. Let's move it up higher. Okay. So the equation of this curve is this one, of course. Okay. So if we want to determine average values of velocity and instantaneous value, we will apply what we discussed in the previous videos that I have with you. So there you have it. This is now our answer for part A only of the said example. Okay, let's further uh, look at the graph here. So if you look at the graph, when time is 2, if I plotted this correctly, when time is 2, you have here the bottom of the curve. At bottoms of curves, the best the best approximation for a tangent line is horizontal. So when I sketch a line tangent to the curve at point 2, the best approximation is a horizontal line for the bottom of the curve. So what does this tell us? We learned in the previous video that the slope of a line that is tangent to the curve of a position time graph, that gives us the instantaneous velocity at that particular time. Another thing we learned in the previous video, the slope of a horizontal line is always 0. So what does this tell us? If I sketch this correctly, anyway, we can verify this by calculation. We are expecting that pagpatak ng 2 seconds while the particle is in motion, it is instantaneously at rest. Okay, did you get that? Why? Because the slope of this line, slope when time is 2, obviously is 0. And it means that this is also the instantaneous velocity when time is 2. So, in other words, when pag tungtong ng 2 seconds, ito, yung particle natin instantaneously hindi gumalaw. Why? If you look, this is if between time interval 0 to 2 seconds, this is where the particle is moving to the left because the slopes of the tangent lines here are facing the left. So if you get the slope of those lines, you'll get a negative number. Negative slope here means the particle is going towards left. And that happens from 0 to 2. But from 2 to 4 seconds onwards, the steepness of your tangent line is already facing the right. So meaning, from this time to this time, the slope here, this will be the time when it's going to the right because that corresponds to positive slope. So at this particular point 2, paano makapuntang right yung particle kung hindi mo na siya hihinto? Tama ba? So from 0, it's moving here at a fast velocity going to the left. Pag approach ng 1 second, hindi na siya ganun kabilis because the line will look like this, the tangent line at 1, less steep than when it was in time 0. So the particle from 0 to 2 seconds is slowing down while it's going to the left. Okay? It stops pagdating ng 2 seconds. So if it's very fast initially and then later it slows down. It stops momentarily pag time ng 2 seconds only to go back to the right again and being faster and faster. So that's the physical meaning of this graph here. Okay? Next video, we will answer the part B of this same example problem.